So welcome back. We are still on objects. So the importance of objects is to modularize, to help your program be broken down into some simpler, small subsystems that you're going to easily program. Another way of using or having the importance of objects is what we call black boxing. Black boxing is when we are able to put our methods and our properties private. That is, we don't expose our code. Our code is normally protected from being accessed by other areas of the code in your module. So that is what we call black boxing, is to make sure you protect your data and your methods. We shall see as we continue that we use some keywords such as private my data, private my whatever. So that is black boxing. The other element we may talk about is encapsulation. So to encapsulate again is to hide some details, to keep some things just private to where they are supposed to function, is to encapsulate. From the word capsule, is you are locking some things from external or from the external world. Another importance of objects and classes in OP is what we call loose coupling. Couple, couple is to bring some two or more things together and make sure they hold together. So loose coupling is simply saying we can make our classes, or we can replace some portions of code in our programming code without affecting the rest of the code or the rest of the system. That is loose coupling. So that means in object-oriented programming, the other word is tight coupling. So we are not tightly coupled, but we are programs are loosely coupled. They can be taken away, they can operate, they can be replaced without affecting the rest of the system. So that means you can easily maintain one section of the program and another section like that without really affecting the entire program as such. So those are some of the advantages. You can also have disadvantages, which is actually the opposite, but these are some of the advantages. So how do we implement classes and objects in object-oriented programming? So classes are normally, we say they are blueprints. So they are normally constructed using the keyword class, and then you open curly brackets. Then inside the curly brackets, you define your data members. That means how many containers you're going to use. Then you, of course, use a semicolon to terminate those statements. And also you define your functions inside there, and you close the curly bracket. So that is a syntax, but make sure you use the word class. Class will be a keyword. So an example will be like class student. Then open curly bracket, then define my student is going to have a name, so I'll have a string name. So I'll use the word private, maybe name is equal to whatever. So you can also store age, say private int age, because the age is going to be stored as an integer, like that. So your data members, in most cases, we normally like to make them private so that they cannot just be accessed outside the class. Then functions, which are function members, we normally use the keyword public to make sure, functions, they act beyond the class. They can, invoke some actions beyond that class where they are defined. So that is why our functions, we like them to be public so that they can go beyond, they can affect, or they can have an activity outside the class. So again, objects, when you create objects out of a class, simply when you have instances, objects, because they are variables, they need to be initialized. So to initialize an object is basically to have the initial value stored. Now, if you don't have a value that is going to be stored in an object, in some cases we say it is void, there is nothing. So void is a data type in object-oriented programming. That means you can store nothing. So we say your class or your object has been initiated to a null value. So initialization is very important, again, because if they are not initialized, they store what we call garbage value, or any value that is given there which you don't know what it is. So it is good for you to initialize your objects, give them some, assign some value. Let us now see, how do we store, how does the computer store objects, and how do they handle memory? Because when you create a variable, like an object is a variable, that means it's a container, it requires to be stored. So how are they stored? We have so far learned in other languages how to store integers and their size limits. You know, integers maybe occupy, the short integer occupying maybe a certain size, you know, floats or occupying a particular size, and whatever. So how do you store, and how much space is required, and how do you store objects? Because objects is a combination of different data types. You can have integers, you can have strings, you can have floats, you can have pointers, and what have you. So how do you store a variable that is made up of different data types? So memory, where it is stored, can be treated as a free store. So memory is either assigned to a variable statically or dynamically. What do you mean by static allocation of memory? Static means that my memory is clearly defined in terms of size and where I'm going to store in my code. So before my program runs, already I have defined how much memory I require and how I'm going to store different data types. Then if we talk about dynamic storage, we are simply saying, can I access more memory than whatever I have declared? Or if I want to access more room or more space, then what do? I have to make sure I access my memory dynamically. So dynamic is to make sure that when you need memory, your program can be given more memory than the one that you have declared in your code. So those are the two different ways of accessing memory, statically or dynamic. But also we have some other ways of accessing memory and probably maybe reading from it. So we have heap memory and we have stack memory. Now when you talk of stack, sometimes we refer to program instructions. How is your program instructions? How are they stored? How are they accessed? So they are accessed using stack memory. So stack simply is a way of popping up and pushing down things. So your memory, when things are stored on stack, that means your program instructions are either popped out or they are pushed in. But also the other way of storing variables is through heap memory. So heap memory is basically like dynamic way of accessing memory, where memory is referenced. By reference means that you can get some extra memory through reference or by referencing to some memory that is elsewhere. Yeah, so heap storage will work especially when your program is running at runtime. Stack memory may be tied when you're doing compilation or at compile time. When you're writing your code, you statically assign, because your program probably instruction does not change, but the data that is generated normally changes as the program runs. But the instructions, they are fixed or fixed size. So they are stored as stack. Then values generated are stored as in heap memory dynamically. So when you talk of static objects, we simply mean that your objects, we are giving them some fixed size, or we have scoped them. Their size is dictated when you're writing your code. So we say an object is static. You cannot add some, it cannot access more than whatever you have assigned to it. Okay, so you can make an object static so that it is basically utilizing whatever has been assigned. Yeah, but when we shall be talking of pointers, we can reference to more memory elsewhere by using a pointer variable. We said pointers are simply storage locations, but they don't store values, they store addresses of another variables. So you can create pointers, and object-oriented language, for it to access more memory, then it has to work with pointer variables so that it can point to another memory or another location using a pointer. Yeah, so I think we can stop there and continue.